We talked about place value system. Now let's talk about something more interesting, something more a bit advanced. What is that? So we talked about how place value system works. So any number, let's say 27 or 127, let's say. I know that its face value is 7 and its place value is 7, its place value is 20 and its place value is 100, and the number is 100 plus 20 plus 7. I know that. And the place value keeps increasing by powers of 10. So this one is 1, this one is 10, this one is 100, and so on. The number of zeros keeps increasing. Before moving ahead, let me tell you what is power, or what is meant by power. Just like power is also called exponent. So power means, when I write like this, it means how many times 10 is multiplied by itself. So 10 power 2 is equal to 10 multiplied by 10. 2 times is equal to 100. 10 power 3 is equal to 10 multiplied by 10 multiplied by 10. 3 times is equal to 1000. So this is what is power. And as you would have noticed, when we are going in this direction in place value system, we start with 10 power 0, meaning 10 not multiplied with itself at all, and any number when raised to a power 0 is equal to 1. So we start with 1, we go to 10, we go to 100, we go to 1000, and so on. Millions, billions, trillions. It keeps on increasing. The place value. Now, the base here is 10. The number which is being raised to a particular power is 10. Such numbers that we always talk about, think about, use all the time in our life, such numbers are called decimal numbers. Decimal number system. Okay, so this is what we all the time use, all the time talk about. When I say 3, people know it is 3 from the decimal number system. When I say 123, people know what it is. 100 more than something, more than 100, 23 more than 100. So we don't even think about it because it is so ingrained from the very childhood in our brains. We only think in terms of decimal number system. But how do computers work? That should be the question you should ask me, and I will tell you. Computers don't talk or understand in terms of decimal number system. But before I talk about computers, let's just assume that I had only two digits to work with. Okay, only 0 and 1, nothing else. In decimal number system, you know that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. Something rings the bell? 10. And in another imaginary number system, let's say there were only two digits that were invented, and now I have to write all my numbers using these two digits. So let's do it. So what will 0 0 from this number system? Okay, we are not talking about this. So 0 means, of course, nothing. 0. 1 means 1, of course. So this side we have the decimal number system which we all know, and this side we have a new number system which we will give a name very soon. Now what happens after 0 and 1? Because I don't have any other digits. So what will be the place value system method look like for such a number system? So in our decimal number system, we had 10 power 0, 10 power 1, and so on. And because why we were using 10? Because we had 10 digits. So in this particular number system, what would be the base? Absolutely right. If you talked about it, it would be 2. So let's the first position, which I don't know what to call it, it would be 2 power 0. The place value in this number system, which has only 2 digits, the place value will be multiplied by 2 power 0, which is 1, right? 2 power 0 or anything power 0 is 1. The second position will be 2 power 1, 2 multiplied by itself only one time. So 2. Third position 2 power 2, which is 2 multiplied by 2 is equal to 4. 2 power 3. So we are finding out how the places, the value for each place will be calculated. And it's exactly like decimal. Instead of base 10, we are using base 2. 2 power 3 is 2 multiplied by 2 multiplied by 2 3 times equal to 8. Now let's figure out a number. Let's calculate 0, 1. So what is this number? Let's write it up. So 0 multiplied by 1 is 0. 1 multiplied by 2 is 2. 2 plus 0 is equal to 2. So 2, sorry, my bad, 1 0 1 0 in this number system which has only 2 digits is same as 2 in our decimal number system. Let's replace it by 1. What will it be? Do a calculation quickly, quickly, quickly. 1 multiplied by 1 is 1. 1 multiplied by 2 is 2. 1 plus 2 is equal to 3. So 1, 1 in this number system which has only 2 digits is 3 in decimal number system. And now let's raise the curtain. What is this number system? It's called binary. And you would hear about binary all the time because computers use binary, and you will definitely learn about binary numbers in more details as you move along in your classes ahead. So this is an important concept. Now let's do something for an assignment. Now tell me, what is this number? Let's replay, let's clean it up, and let's write 1111. Okay, so what is this number in decimal? So this is a binary number. So let's calculate. 1 multiplied by 1, 1. 1 multiplied by 2, 2. 1 multiplied by 4, 4. 1 multiplied by 8, face value is 1, place value is 8. What is this number? Addition of everything. 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15. So 1111 is 15 in decimal. Binary 1111 is decimal 15. So, and this is the language of computers, zeros and ones. You would see all the time people telling that computers understand only zeros and ones. What does that mean? Computers understand binary. Now something related to binary. It's not very easy to understand, right? 4 digits and it only is 15. And it's not very difficult to understand. It's not very natural. So what computer scientists the world over did? They came up with a new number system. So instead of binary, they will not use decimal. They started using base 16. So what does that mean? There are 16 digits in this number system. What are they? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What next? A, B, C, D, E, F. So interesting, so cool. What is A? And this number system is called hexadecimal. Hexadecimal. Okay. So what is A? A is a hexadecimal digit. What does it mean? It means 10 in decimal number system. B is 12 in decimal. B is hexadecimal. 12 is decimal. I'm just trying to give a comparison. What is A? What is B? What is the value? Similarly, F. So 10, 11, 12, 13, 14, 15. So F is 15. So what does it mean? That this number is same as this number. This is binary number. This is decimal number. And this is hexadecimal number. So F is equal to the value of all these three is same. The number system being used is different. Now let's do another calculation to avoid confusion. Okay, let's calculate what is the value of 15 in hexadecimal. Okay, it's I hope it is not getting too confusing. By the way, this is an advanced topic for grade 6, so it's okay if you do not understand. So here is the summary. 1111 in binary is same as 15 in decimal number system where we have 10 digits is same as F in hexadecimal number system where we had 16 digits. Now let's do some examples. So in hexadecimal there are 16 digits. So what will be the powers to calculate the place value? 16 power 0, which will be 1. Anything raised to the power of 0 is 1. 16 power 1 is 16. 16 power 2 is 16 multiplied by 16. You can calculate. So like this, the place value will increase in a hexadecimal system. To avoid confusion, let's say 1 and 5. These are digits in decimal number system and these are also digits in hexadecimal system, right? So let's find the value of 1 5 in hexadecimal. 1 5. So we know that 1 5 is 15 in decimal system. We know that. Now 1 5 in hexadecimal, what will it be? So 5 multiplied by 1 is 5. 1 multiplied by 16 is 16. 16 plus 5 is 21. So 1 5 in hexadecimal is same as 21 in decimal. I hope you all are not pulling out your hair by now, but keep watch this video one more time maybe. Another important concept, I mentioned that computer scientists came up with this place value system for hexadecimal because it was difficult to read binary numbers. Now you would say even hexadecimal is not very easy to understand and it is so complex. But the reason it was done was that now see the pattern here. Only one digit is needed to represent four binary digits. Now this is the largest four digit binary number because we only have zeros and ones. So 1 occupying all four places means this is the largest four digit binary number. And what is a binary digit called? Bit. So you only need one digit F to represent the maximum value of 4 bits. What it means is 4 bits or any value represented by 4 binary digits or bits can be represented by one hexadecimal digit. This is the reason hexadecimal number system was created to represent binary numbers. This is the main reason. Now it's okay, you can skip it or you can watch it, but it is super interesting and computers are everywhere and you know about binary digits, bits. 8 binary digits are called, you already know maybe, bytes. And you know about kilobytes, megabytes, gigabytes. You want a bigger computer with more RAM, more storage. I want my hard disk My hard drive is 500 gigabytes. My RAM is 8 gigabytes. My phone has 4 gigabytes of memory, 8 gigabytes of memory. You already use all those terminology. So binary is everywhere around us. Keep learning.
Hello, welcome to the post credit scene. And I'm so excited that I'm going to say hello, not just in English, but also in binary. Yes, this is hello in binary language. This is HELLO. So to know more about it, you will have to understand ASCII notation, which we are not going to worry about right now. But what I want to tell you is that binary for computers, it just not deals only with numbers. It also deals with language. For English alphabet, for all languages in the world, for all different types of symbols, dollar sign, rupee sign, pound sign, brackets, everything has a accepted binary notation, meaning how that symbol will be interpreted by computers. And why do we worry so much about that? Why have we converted or created a binary notation for each symbol? Because computers only understand binary. They only talk in terms of zeros and ones. So let's understand why. But before we understand that, we have to go to the very beginning, to an element, silicon. Where is silicon found? It is most commonly found in sand, actually, our common sand. And silicon is a very special element. It is used in electronic devices. Why? Because it has a special property. It is called a semiconductor. What it means is that in certain conditions, electricity, the electric current will pass through silicon, and in some other conditions, the electric current will not pass through silicon. That's what makes silicon special and a semiconductor. Okay, now what to do with silicon? Then comes the story about transistors. What is a transistor? Transistor is an electronic device. You see it here. I mean, it's currently a huge version of transistor. It is made from silicon. So that is the connection. Transistors are made from silicon. And among other things, we don't have to worry about the details. Among other things, a transistor can act like a switch. So what does a switch do? A switch can be on or a switch can be off. So this is where, do you see the connection? On can be thought of as 1, off can be thought of as 0. So this is the connection. Now we are getting to the climax of the story, why computers understand only ones and zeros. So this was transistor. Transistor is made from silicon. Transistor can act like a switch, on, off. Now, transistors are used to build something called logical gates. It's a difficult word, right? I don't know what it is. So let's just assume it is some kind of a gate. Think of a gate like a door, and logical meaning it is like an intelligent gate, meaning it understands. So our brain, think of our brain as a gate. When somebody says hello and smiles at us, what does our brain tell us to do? We smile back. If somebody says jerk, what does our brain tell us to do? We frown. We show a sad face. Similarly, electronic devices, transistors, are used to make logical gates. These are like small brains of electronic devices. It is very simplistically that I am explaining, but logical gates are then used to build computer chips, like our central processing unit in computer. I will tell you an example of a logical gate with the help of a teenager. There are several types of logical gates, right? So let's say this teenager is like a logical gate, a not gate, meaning whatever you tell this teenager, yes, do this, do that, please, what will be the output? The output will be no. So similarly, transistors are also used to create some logical gates. In what sense? There will be some input at the gate. There will be some input which will be received by the gate. Some logic will be applied, and then there will be some output, logical gate. And then we put a lot of these logical gates onto a computer chip, on a electronic chip, like a central processing unit. Now, what you see on screen is a simple example of a computer chip, or you can call a computer circuit, digital circuit. These symbols we don't really need to worry about too much. What is this written doesn't bother us right now. But ultimately, this is some transistors, one or more. This is some transistor, one or more. These are gates. Okay, this is one type of gate, this is another type of gate, logical gate, and these are made of transistors. Transistors are made of silicons. Each gate gets some inputs and they give some output. A transistor is used to make gates, and a transistor can be on off. So input to transistor is also in those terms. What is the input? Input comes in the form of current. So a transistor can be on, can be off. So this is the story behind why computers understand only binary, only zeros and ones, because they are made of such digital circuits that are made of logical gates that are made of transistors that act like a switch, which can have two states, on, off, transistors that are made of silicon. So that's the story about binary and its importance for computers. Now, do you know this is a modern central processing unit? Do you know how many transistors are there inside this computer chip? It is several billions. Yes, you heard it right. There are more than 4, 5, 6 billion transistors in this tiny computer chip. I know it's crazy. The technology is so crazy, so cool. And before I forget, this circuit that we saw, this digital circuit, it adds two binary digits, 2 bits. It is called half adder. You will get to know more about the details in this reference link. Thank you for watching.